Thank you again. I'm sure you'll do an intro, but we know you've talked at Black Hat. You did a lot of work with VoIP. I'm sure you're going to talk about that as well, but now you're going to do some adversary emulation. And I, for one, am definitely looking forward to this because I know you have your own C2 as well. So go for it.
Thanks, Matt. Thank you for everyone. Sorry for this bump, let's say, because GoToMeeting is something new to me. So in this presentation, I will try to talk about a certain purple team type. Probably you also look for something practical to perform as a purple team or maybe a red team, but there is no package like that in the wild. People try to find some TTPs and tradecraft from the different trade actors, try to construct that and make it a kind of scenario to run against a certain target. And this really depends on the environment. And if you are a new purple teamer, you don't have anything as a kind of package. That's the kind of issue. In this presentation, I will try to answer that question, how we can make a package as a kind of starting point. But also I will explain my adventure while building this. In addition, I will also share a kind of a long training video set with that. Simply, I worked for a couple of things, and in this presentation, you will have a very practical purple team for yourself, and you will also learn how you can customize this purple team exercise and changing the threat actor to another one, and also making it beneficial for your teams. I will also share my weaknesses because this exercise is not perfect. It has some issues, glitches, as well as it has something to improve as well for each section because I had limited time. So I will give all of those to you as well. I will try to fit everything in this next 30 minutes, but take your time because the repositories already have 4.5 hours training videos, as well as more than a couple of hundreds of pages documentation, as well as tools. Today, I will talk about TA505 Tradecraft and how we can utilize this against the cutting-edge systems. My name is Fatih Ozavci. I worked for adversary simulations and security research for a while. Actually, I have 2 decades of experience, but last 5 years focused on specifically adversary simulations, emulations, and security research around the trade actors. I currently also study in Master of Cybersecurity in UNSW. Previously shared some security vulnerabilities with different vendors. I have presented in Black Hat USA, DEF CON, and Europe several times, and I have shared some of those vulnerabilities. I also provide 2 mainstream tools, but also some quick tools and toys for you to play, and I will actually introduce some of those in this presentation. When we start discussing about the adversary simulations, we have some issues about the terminology. So I will set the terminologies for everyone for this presentation context, as well as I will talk about TA505 and how I implemented this as a kind of purple team exercise. Of course, it is not realistic because I was trying to get TA505 plus instead of the TA505 because I updated almost all tradecraft. In addition, I will share how I executed this, and I will give you some suggestions to utilize this in your environment. So it is actually quite useful and beneficial for you if you plant some flags and adjust some telemetry for yourself. So simply, adversary simulations have different types. I love some of those types, such as red team, purple team, and sometimes automated stuff. But we need to set the terms first, okay? Red team is threat intelligence based adversary simulation, and it is dedicated to assessments, security assessment. Purple team, on the other hand, it is a collaboration exercise. So we work together to uplift the defense itself. It's not only focusing on the assessment, it is more like uplifting the capabilities, people, and tools. In addition, we have automated solutions, and those automated solutions give us real-time and some permanent assessments, checks, and telemetry, so we can see that our controls work or not. There are some solutions for almost all these 3 and every one of those certain levels. There are commercial products, open source products, but I will talk about specifically in adversary simulation context today. So you can make it a purple team. It is suitable to purple team mostly, but you can make it also automated as well as red team. And I will explain how you can automate this exercise as well. We need to focus on one thing though. What are we simulating? Because if we focus on a certain trade actor, there must be a motivation behind of it. Some organizations focus on regulations, some focus on their previous security breaches, and some of those only develop exercises based on their trade intelligence data, potential enemies. So we need to focus on those trade actors to understand their tactics and tool sets and all the information. That's why we will actually customize our exercise. We need to use also a common language. That's why MicroAttack is a great common language and everyone speaks that. That's why you are actually getting bored whenever you see something like that. But it is good because we speak same language. I need to introduce you the TA505 because TA505 is a threat actor actively targeting the financial institutions and some large organizations. It may not be active in your specific area, but it is quite active in APAC area, Europe, USA, as well as targeting some Australian entities and organizations. They actually repurpose some of the existing tools or open source products, as well as they use some pirated editions of commercial tools such as Cobalt Strike as well. So they have a combination of open source tools, their own custom tools, as well as Cobalt Strike and some other additional tools such as TinyMet as a kind of loader. They actually constantly change their tools and they update this tradecraft for certain reasons. They are not a kind of passive trade actor group, just like uplift this whenever necessary. You know, they continuously update their tradecraft. They put new the ransomware, new blockchain miner, or they focus on certain privilege escalation things. Even they started using NetLogon vulnerabilities recently published immediately. So they have these capabilities. So I thought that, okay, what should I do with TA505? Because I had a study, a practical project to prepare for my cyber offense course in UNSW for Master of Cybersecurity. And in this practical project, I decided to uplift their tradecraft already and focus on TA505 Plus, which is a new trade actor, just I imagined. And it is mainly utilizing almost all cutting edge techniques, such as utilizing the .NET features. Because Cobalt Strike has this execute assembly feature, Covenant, Silent Trinity, there are lots of .NET tools around. So they may start using .NET tools instead of using their old tool sets. When they change this perspective, what would we do? That was the question motivating me to prepare this. So this presentation is based on this .NET Tradecraft, as well as some custom tools used. And I utilized Petaq C2 that I have developed last year and released around March, which is a proof of concept tool only. May not be suitable for a production environment, but you can use this for several different test cases. I started with their tradecraft. I started with their techniques to understand this TA505, as well as map them to my point of view. For example, I changed their loaders with a custom new loader, Petaq Dropper or something like that. I changed their C2 environment, Cobalt Strike, with another environment, which is Petaq C2, using WebSocket instead of the regular HTTPS. I also used the similar Metasploit connections as well, because active exploitation during the lateral movement or actions on objective stages, they may need it. I also changed their techniques as well. These are the techniques listed in the MicroAttack profile of TA505, and I simply implemented some of those, not all of those, of course, because they haven't used all of those techniques in one single campaign. They are active since 2014. So simply they have used different techniques, different types of tools and the tactics actually for different campaigns, different targets. So I tried to implement most of those. I also developed some tools for it. For example, they use ransomware, and I didn't want to use a kind of ransomware in our production environments. I just provided a ransomware bokoblin, ransoblin for this. So it simply encrypts things for us and also decrypts. So if you want to encrypt something or decrypt something, it can be used, but it doesn't have the other features such as volume, shadow, copy, disable, or remove files, and etc. They are slightly invasive testing. I haven't implemented those, but there are some tools I have developed for those techniques as well. And I mainly use, as I mentioned, .NET tools. I didn't use LOL beans, leaving off the land binaries. There's a reason for that. I was focusing on the .NET Tradecraft, but you can enrich this using the LOL beans because TA505 actively using LOL beans. That includes Windows Defender download capabilities or MSI exec to download and execute things, or signed third-party DLLs. I actually constructed a kill chain for this exercise. Each kill chain item phase had another set of action for me. The first one was reconnaissance, but I was the threat actor and there was no specific target. So I implemented this as a kind of threat intelligence collection and making this tradecraft working for myself. In addition, I also worked on weaponization. Weaponization phase is the most important phase of any campaign performed by threat actors or red teamers because we developed a lot of tools as well as techniques and we configure our infrastructure in that phase. And it is almost getting maybe 60% of our entire time. Then we deliver the attack, and this attack simply compromises the target. In that context, I used Excel file just like TA505. Instead of DD, I used something else, which is Excel for macro. I use Petaq loader, which is loaded through that way in this Excel macro. And it simply disables AMSI in case of any other tool upcoming will be directed by Defender, and it actually loads Petaq C2. So it was a kind of environment for me. So I developed some custom tools as listed, and I will talk about them shortly. In addition, I had a delivery section. I use assume breach. Assume breach principle says that the threat actor has some sort of access anyway, and then what can be done after that? For example, I simply saved an HTML file, just like an email, instead of sending an email and testing SMTP. So we start with that email and assuming that that email landed to the user email boxes anyway. So what happens after that? So the exercise starts from that moment. So you can add that SMTP and mail sending component to test your mail gateway security. That's up to you, of course. But you need to implement this yourself. Otherwise, it is a kind of full exercise. It delivers the Excel file allows Petaq implant to run and connects to the Petaq service. During the exploitation stage, it also performs some sandbox escapes for Excel macro run, as well as AMSI bypass, AMSI patch, also stealing tokens from system. So it's quite excessive. Of course, installation is a kind of permanent auto run key for registry and using command and control in several different ways and utilizing some actions and objectives. This was my point of view. So I actually implemented this in my local, but you can actually deploy this to your cloud instances or your test environment as well. This is how we deploy. We have C2s, proxies covering that C2 environment with different redirectors, phishing environment, monitoring environment, and whenever we build a kind of telemetry around this, we will be quite good to go. However, the command and control server will be a key component we need to work on because almost all operations will be passing through this command and control channel. So we need to rely on what the threat actor uses. Threat actor was using Cobalt Strike, which is a commercial tool, also a favorite for red teamers as well as threat actors actively using. What the problem there is, I cannot use Cobalt Strike for everything in this context because it's a commercial tool. So I used my Petaq C2 to replace this. In your context, you can use several other tools as I listed here. There are safer C2 choices for you. Site is commercial as well as safer to run these exercises. Also, it is flexible to automate these exercises as well. Cobalt Strike has a scripting language. There is no automation or purple teaming like telemetry or other stuff on it. So it is more like a red teamer or threat actor tool. Covenant and Silent Trinity, they are open source tools and they are quite useful for purple team as well as red team exercises. That's why I can suggest those 4 tools. However, I have used my own tool, Petaq C2, and there's a reason for that. First, I'd like to customize my environment. Second, I don't want to use the same signatures I have used everywhere, okay? Petaq has almost all important functionalities for me. Utilizing a .NET assembly in memory, compiling a .NET assembly, giving interactive .NET environment for me, just like Python shell. It's a C# shell. Also, shellcode injection for any shellcodes, commands, PowerShell. Also, running PowerShell and PowerShell automation. They are good features for me, so I can build something on it. Moreover, it has nested implant feature, so I can just connect the implants to each other, as well as I can get just one single HTTPS WebSocket out that allows me to hide my activities. And finally, I have added also scenario-based automation, even though it requires JSON, an influence of JSON DLL as well. It simply parses JSON and then automates the tasks for you that I will demonstrate today. I have developed some custom tasks for this exercise. They are all available. These addresses are currently up and running, and you have a lot of documentation as well as videos. So you have the presentation, so you can start working on this. Petaq Dropper is the initial loader. It simply loads .NET assemblies, which are initially AMSI patcher. It will patch the AMSI. Second one is the implant itself, which is Petaq implant. Petaq implant is a malware, a simple malware, but works well for the simple functionalities. So it allows you to run .NET, PowerShell, or system commands, or process injection. Petaq service is the C2 working in HTTPS part. But we need also initial files, right? In that manner, I have used Exal.NET. Exal.NET can generate Exal4 macros that you can use to craft certain Excel files for yourself. I have also a training video in that project for this. So I have actually put Petaq Dropper in it. Also, I have ransomware, and I have also some additional tools such as AMSI Patcher and etc. AMSI Patcher is slightly important because AMSI Patcher is replaced version of Rastamouse AMSI Patcher because it is identified, it is detected by Windows Defender. You need to change a couple of things. Strings are, yes, important to change, but I also changed Marshall copy with write process memory Windows API that allowed me to bypass Windows Defender. You can check it out. My target environment in my mind was an employee desktop, which must be highly protected. That's why it is Windows 10, as well as Office 2019, fully updated Windows Defender enabled, and everything was restricted. So I am targeting Excel 2019. With all the sandbox features and security features enabled and highly restricted. I also put two vulnerable systems in the back to demonstrate some lateral movement and actions on objectives part of it. So this is the sample network, but you can just customize this. It is up to you. You can install your targets as you desire. This is how we start working on. Initial compromise is designed as stages because normally TA505 also lands as stages. But this stage approach also beneficial for the training purposes. For example, you can train your blue teamers using this perspective and plant some flags for each of those. So Excel file loads the Petaq dropper, which is the C# application. It gets AMSI patcher from remote to disable the AMSI, and then it runs the Petaq implant itself, and then it gets the control. And this is not detected by Windows Defender yet. However, you need to change the binaries and compile stuff. Don't use everything as is. Recompile or prepare your Excel file as videos instructed. Internal implant communications are designed like that. I have used Petaq implant, so Petaq implant can manage the other implants as well. That means the black one is the original implant connected to the C2 using WebSocket, but the purple butterflies, which are also Petaq implant, are using assembly named pipe, TCP, or UDP running on different systems and connected to each other. So linking system works here, pretty much like Cobalt Strike linking. And it is quite valuable for this environment. I also plan to fork a Metapeta instance for the Metasploit demonstration as well. So that's the plan. The other one is actions on objectives. Actions on objectives need two different approaches because TA505 have used Cobalt Strike. So I implemented those attacks on Petaq C2, which replaces that one. The second one is Metapeta. I used some Metapeta features to demonstrate through this environment. And also they were not detected by Windows Defender either because I had a kind of harness around it. For lateral movement phase, I also use some exploitations and some documented vulnerabilities already because the systems were quite vulnerable. But that was not the point. The point was how we can use lateral movement through this initial setup, the Petaq implant as well as metaperimeter tunneling. So defense evasion techniques used in the wild have been grouped in a couple of major groups, such as AMSI bypassing, which is anti-malware scanning interface for the Windows Defender, as well as some other antiviruses. And this is important for Windows Defender cases, but it is not exactly key for other EDRs. If there are other EDRs, you need to use unhooking techniques, or you need to use a kind of kernel driver to get this around. I also replaced the Marshall copy with write process memory in Rasta Mouse's MC bypass patch. So you can just reutilize this, and it is currently not detected. Event tracing for Windows is a main enemy of the .NET Tradecraft because it actually gives you a lot of information about the .NET Craft running. So we can add some protections there. However, TA505 have not used .NET yet, and I was uplifting this only one single level. So that I didn't add anything regarding ETW bypass or manipulating or mangling the binaries. Kernel security and driver security exploitations, they are just out of scope for TA505, as far as I know. They were used by some other threat actors. So if you want to enrich your environment, there are some kernel driver bypasses and some vulnerable drivers, as well as some signed drivers that allows you to load some vulnerable drivers as well. So you can just enrich through that way. I only implemented Rasta Mouse at a MC patch here, which is replacing the Marshall copy with write process memory. I also resurrected one UAC bypass, which is another case, and there's a demo for it as well. It was actually following a certain registry key for any command would be harmful, and I just changed it, and it worked very well. So I resurrected all techniques simply for this purpose. I didn't develop new ones. For execution, keep this in mind. We need to make everything aligned with multiple teams, right? So SOC teams, defense teams will receive the telemetry information not in real time. Sometimes they get this in 1 or 2 minutes, but sometimes it will take up to 3 days. The reason behind of it is the environment connections, because sometimes we work from home and remote connections do not give enough flexibility for the EDRs if EDR doesn't use cloud services. It is similar for Windows servers as well. They may give you a lot of telemetry information as data source to push to Splunk, but Splunk will give you this until actually, Splunk should wait for the data source to ingest this information. That means the server should push that log first. So there may be some delays there just because of this environment, or maybe just because of the network issues. The other thing is you need to build some queries on Elk or Splunk to understand the telemetry of this. So purple team, that doesn't mean that run an attack and see what's happening. It's more like let's collaborate. That means you need to give enough time to blue teamers to digest this information. So I suggest you to split this to multiple days and run each phase or each step against the same environment and wait for blue teamers to see the telemetry itself. Not the detections, not the alerts, they are different stories, but at least they should have some telemetry. Missing telemetry, permanently missing telemetry is a finding, that's all right. But if it doesn't work or it works with delays, we need to also pay attention to that one as well. You can also plan some flags for this. So it will be a CTF-like exercise for them, encouraging them to move on. Add a kind of facilitator there to maintain the balance between red and blue. They are not fighting, they are actually collaborating. So keep the pressure up, but make it also friendly. That is quite important for almost all teams. So share everything with blue teamers, so they will work on it and they will build some signatures for it. Plant some flags is a good suggestion, but where should you plant those, right? That's the question. The answer is quite simple though. If you want to improve your capabilities, team capabilities, such as your people, you can plug almost all these flags to your implants or your C2 communication protocols. So Petaq would allow you to add some certain key keys or certain characters there, or you can make them questions yourself. For example, what is the endpoint connected as C2? What is the string passing through between implant and server? So they have to use HTTPS interception, for example. What is the string in the dropper? What is the string in the AMSI patcher? What is the string in stage 1 or stage 2? Or what is the service identifier created through WMI? Those are the flags that allow you to actually improve and monitor this environment. I suggest you to use external tools such as Red Elk. Red Elk gives you a lot of telemetry on the red team part. So you can see how your blue team tools or people work. If there are tools pushing out the malware directly to the services such as VirusTotal or AnyRun or something, you can identify this easily. Or if someone is working on your background, your infrastructure, you can see this. Unwanted victims, they can be seen. Or a kind of malware starting with stage 3 or something. That's an interesting approach, and you need to see this as well. That's why Red Elk allows you to monitor all these environments. I suggest you to use something like that. In addition, Vector can help you to facilitate this exercise and monitor everything and keep the language same for everyone. So those are good tools in my point of view. Also, uplift your game after the first exercise. Change your C2s, make them cloud native. Just work on C2 traffic cloud, or maybe just use additional domain fronting features or change the protocols. Those are important. Also, uplift your defensivation techniques. If you only bypass Windows Defender, it's a good start. But how about EDRs? Maybe you need to load the NTDLL and remap the API calls using process environment block and then just move on. That's another way. Or you can just work on the kernel space, or you can do a lot of stuff actually. Those are actually uplifting game for everyone, blue team as well as red team, because eventually trade actors will see this. One more thing, in my exercise, I had also specific sections for recommendations and feature updates. For example, in ransomware, if you want to make this realistic, you need to add a volume shadow copy feature to disable this, or you can add your Mac version, or you can just delete the file as a kind of option. Or you can just reschedule your stagers, and they can arrive in time if you use automated features. They're all documented, so you can take a look at the documentation. TA505 Plus is the repository for this purpose. You can check my GitHub. And the other thing is, I have a video set for this. It is 4.5 hours, I think, at least more than 4 hours. So you can just start with that playlist. But don't assume that playlist is accurate path for yourself. Please pay attention to the names and focus on what exactly you need. I try to explain the weaponization phase, reconnaissance phase, or delivery based on what exactly I'm trying to achieve. That means, for example, weaponization phase would have Petaq implant in a different place, AMSI bypass in a different place, or UAC bypass in a different place. So you can see how I constructed them one by one, and then how I merge them. I will show you one execution only. In this case, we have this video. It's a small video extracted from the real life recording. This is the virtual machine on the left, and the right, there's also Petaq C2 must run. On the left, there's an email simply saying that, hey, Jack, there's a kind of system here. So we are working on some financials. Just a sec, I need to play this. I hope it plays. I'm not sure it is playing, but the good news is it is already on the repository. Yes, it is actually jumping, but I'm not sure video streaming as well. Do you see the video flowing?
It's going through very
It lags, right?
Yeah, it's very slow.
So I need to I need to change this, I think. I will just change it. Would you please bear with me, because this part was the key, but because of this network, I think it had issues. I will just make it running back again. Yeah. Let's try this one more time. No, video has issues.
Yeah,
That's
and
one of the,
yeah, what Adam
yeah.
did posted on the Discord link your YouTube channel and the playlist so that folks can take a
Yes,
look at that on
that's
there.
that's the good part. Yeah, I will just move on as video played, but you can. It is currently active anyway, so you can just start with that video. I'm just playing from start. You can see my screen now, and I will jump to the final part. Yes, this is the automation part. We have the video, so you can go to the 4 hours video section. There's a kind of path for yourself anyway, if you have the presentation. I will also upload this presentation to my GitHub repository. But what if you want to automate this? Because we run everything one by one every time, and this consumes a lot of resources. Automation is a great way to test the tools as well as resources, as well as people. That's why I added automation features on Petaq. Petaq's automation features are quite immature. So you can consider some commercial applications such as site as well. What we can do here is building a scenario. For example, this user will receive a certain link, and that certain link will allow attackers to get this endpoint compromised. And when you compromise this endpoint, you can just perform some certain actions. That is the scenario. And in that scenario, you can also implement some different TTPs. I simply show you the scenario content for Petaq. This is a sample scenario, and the sample scenario has only TTP IDs. They are file names actually, saved under the Petaq TTP folder. So simply, it will include those files and construct a kind of scenario, and we'll send this to the implant. And implant will run this and generate a certain report for it. The TTP content, on the other hand, is quite flexible. It is, again, JSON, and I put a simple addition of this TTP. This is one single TTP saying that this is my Tradecraft ID, these are descriptions, I copied, pasted, and these are the instructions. Instructions is an array, so you can add multiple implant commands there, because we may have multi-steps or multiple commands for one single TTP. For example, disable volume shadow copy, delete this file, and do this or something like that. It is similar for all trade actors in this point of view. However, the good part is actually Petaq supports multiple operations such as uploading file, linking implants, execute .NET assembly, compile .NET source code in memory, use .NET Direct Shell, execute PowerShell in the system management automation, or just inject some certain codes. And you can use some third-party tools here as well, such as PowerUp, Mimikatz. It's all up to you. And they are just one single line saying that, for example, shellcode, invoke this shellcode, or exec let's say, .NET assembly and run, let's say, seatbelt for situational awareness. Just one single line. Examples are already in the repository. And this is the second video. This is only 2 minutes video, but I'm not sure whether or not it will start. I started this, and yeah, it started. Good. On top left, we have our victim. On bottom screen, the console, we have Petaq running. So we have 2 implants connected here. On the right, also there are some other VMs. The first top is the Windows 10. And the other VMs, smaller ones on top right, they are actually servers, Exchange, and also domain controller. And in this context, I'm just showing a couple of commands of our Petaq. For example, exec PowerShell, this code, or exec command. It also supports a lot of different things, as I mentioned before. For example, exec sharp direct will work just like C# shell, just like Python shell or your bash shell. So you can see this. The good part is we can automate this, right? So this is how it works. There's no scenarios running yet. And I'm just saying that scenario command and use this implant as well as this file. And this file has a scenario, right? I'm just copying and giving the path of scenario, just like I have shown you. It simply constructed the scenario file using the TTPs given, sent this file out to the implant. Some of those are shellcode injection, popping up some calcs or running some codes, running some power-ups and etc. or seatbelts, and giving the results to us. When this finishes, we receive a certain report. I actually show you how it works on top as well, because I use very verbose mode there to debug everything for you. And on the bottom screen, we will receive a report and saying that, yes, the exercise is done, the scenario is done, and we receive this report. The report may have 3 different views for you. One is a simple update saying that this MyTradeC ID or this TTP did run. This TTP did not run. This has been done. This did not, or something like that. But it is quite simple. On the other hand, if you look to the output is quite different and excessive, and it will give you a lot of details. In the output, we also show command execution results and other stuff. So it is quite excessive. I just show the summary for you. You can also export this summary or detailed files to external files as well. So you can work on it. Or you can just automate this scenario again and again until your defense tools start identifying those telemetries or alerts. This is how it works. And I'm using, again, output this time. And this output will show you the details of the actually commands. There's a detailed video for this anyway. It is 8 minutes, and it describes how this output has been generated on the implant side. So I'm just moving to the conclusion. We have different types of exercises, but we need to find something tailor fit on us. We need to choose right trade actor. We need to understand what type of adversary simulation we are chasing, red team, purple team, or automated versions. If so, how we should implement this. So it must be exactly fitting on our profile. We need to develop some stuff so we can customize things, and that will test our defense better. In this TA505 walkthrough, I also have identified that TA505 can still walk through newer systems with minor modifications. I have just resurrected AMSI patches, resurrected UAC bypasses, resurrected some token steal information because MetaPetaq couldn't steal the token from system. I did that. So there are things I have to tweak, but they work well against Windows 10, 2019 Office, as well as Windows Defender, all up to date. In a summary, in a nutshell, we see that purple team exercises are quite beneficial for everyone. It simply improves all of the defense, and it actually gives a lot of different benefits as well as assessment results for us. We can see that our investment is good or not. So specialist first in my point of view, and then software. So pay attention to your team. These are references. Please feel free to take the screenshot now or walk through the presentation. You can jump directly to the GitHub repositories. Everything is there. Video links, documentation, sample codes, and sample implementations. And yeah, thank you for listening to me.